So what we're going to do here, I just want to look at this quiz before we move on, okay? Just so you guys are good for tonight, submitting that thing tonight, okay? Expand means give me a, I suppose the other word could be distribution. This is what this means, okay? And then distribution was like kind of the arrows, or like multiplying this and this and this, or you could use FOIL, or you could use the table method, okay? I gave you 3 different methods to do these questions, okay? So I saw I don't know, the table to me is like, you can't make any mistakes by using the table, right? And the table just says, okay, I'm going to take my length and width, and I'm going to write them on like as if it was a square, right? So I'm going to say, okay, x plus 5, and then I'm going to write the width down the side, x minus 3, and then I create a table. Right? And you fill in the middle of that table with multiplication. So x times x is going to be x squared. X times 5 is going to be 5x. Negative 3 times x is negative 3x. And negative 3 times positive 5 is negative 15. Okay, this one gave some people some problems from the perspective that they did all this perfect. We did the x squared, the 5x, and the minus 3x, fine. But then we just decided to go, oh no, I'm not multiplying for the last one. I'm just going to go 5 minus 3 equals 2. Right? We just changed our minds in what we were doing. We're not allowed to do that, right? You always got to multiply when you expand. You can't just decide to go 5 minus 3. Okay, so we had the work right. We just had the wrong answer at the end. Okay, so the last step here when expanding is to write all of the inside stuff, the area, in one line. Okay, well, I'm going to get x squared plus 5x minus 3x minus 15. Clean up the middle too. Okay, that should be the answer. Okay, that's what you would leave. Okay. Now here's the catch. If anybody doesn't have any questions, you can type in the chat if you have any questions. But all 3 of those methods that I showed you will produce the same result there, that answer. Okay. So if you didn't get that answer, try and figure out why. I tried to put in the notes why you didn't. There's a solution anyway. Okay. For the second one, if you guys remember, we did a little bit of discussion around what x squared meant. Well, that means that there's 2 x's multiplied side by side. Okay, x cubed would mean that it's x times x times x, and so on and so forth, right? So all it's saying is that if you see the squared here, it just means that there is 2 of the same set of brackets, right? So we're going to say, okay, this is the same thing as writing x plus 5 multiplied by x plus 5. Right? And then at this point, you can just apply your table method that you used over here. So you write, okay, my length can go on top, x plus 5, and then x plus 5 can go down the side. Create your table. Okay, fill it in. X times x is, x squared, 5x, 25. So if I were to rewrite the inside, remember the area, I'm going to rewrite the blue section in one line. Okay, I'm going to get x squared plus 5x plus 5x plus 25. That's equal to x squared plus 10x plus 25. Okay, does anybody have any questions? Expansion's like the easiest of the 3 that are on this page, I think, right now. It's when I provide you with the question that looks like this, then I ask you to go into the reverse direction. The reverse direction is what we call factoring. That's the harder process. Okay, and that's what we have 2 questions down here to look at. how that's done. Okay. Does anybody have any questions? Remember, this direction is what we call factoring, right? And the question itself is when I provide you this, which you turned into this, and this is the process by which we call expansion. Okay, expansion and factoring are opposites. They take you in different directions. Okay, and they yield two different forms of the same parabola. Right? That's all these things do. There's just two processes that I've shown you. Expansion was a process. Factoring was a process. They take you in two different directions so that you can answer different things about this particular graph. A parabola. It's starting to look messy with the grid lines. Right? You can answer all sorts of questions with both of these forms. Remember, both of these forms represent one parabola that tells us different information. Okay? Does anybody have any questions? That's the expansion. Okay? If I were you guys, I'd just use the table. The table seems to... I have a hard time making a mistake using the table. I have a little bit of an easier time making a mistake if I'm using the distribution. But I'm not going to say do it one way or another. You guys are free to choose one of the three ways that I showed you. Okay? All right. Let's go down here and factor. How are we specifically factoring? By finding the greatest common factor. Okay? What does that mean? It means find the biggest thing that can go into both terms that you see. Okay, for this particular question, it looks like, and remember the greatest common factor is comprised of numbers and variables. Okay, so you're looking for the biggest number and the most number of variables that you can take out of the entire thing. So let's just take a look over here. You're going to deal with the numbers first, right? It looks like I can divide both of these by 3, because 3 would be the biggest thing that goes into both. Right? So that means my greatest common factor for this question would be 3 so far. And now I'm going to check, right? That takes care of the number portion of my greatest common factor. The other piece you have to check is if there is a variable. Oops. Is there a variable that you can take out of both terms? Well, the only variable I see in this question is the x. Okay, but I don't see an x over here, which means I can't take it out of both. I can only take it out of one, and I can't do that because what I take out of one, I have to take out of the other, right? And so it doesn't work. I would have to have an x here in order to be able to take it out, and I don't. Which means I don't have a variable. There is no variable in this question that I can remove in my greatest common factor. So here's the other piece that people did the inside of the brackets good, right? The one piece they missed is your greatest common factor has to go out front. You have to write it. It can't just disappear, right? And then you tell me what's left after you remove that greatest common factor. So it looks like if I divide 3 by 3, that would be 1. You'd be left with just the x, 1x. And 6 divided by 3 is plus 2. That's your final answer. Okay, that's it factored using the greatest common factor method. Okay, if I go over to this other question, B, and I look at what's going on there, I'm going to try and create my greatest common factor by looking at the number first. Well, it looks like all of those are divisible by 2, so I'm going to start with the 2. Right? I can divide them all by 2. That's a correct statement. Then you're going to look at, okay, well, what's the variable that I can remove? The most number of x's, it looks like, right? That's what I'm trying to remove, is the variable x. Well, it looks like I can only take one x because I only see one x here. I see 2 here and I see 3 here. But I can only take 1, right? Because there's only 1 in that last one, right? So my greatest common factor is 2x. That means I'm going to write out 2x, the greatest common factor, goes in front of the brackets. What goes inside the brackets is what's left after I do the math on each of these 3 pieces individually. Okay, so it looks like 2 divided by 2 is going to be 1. One of the x in the bottom is going to cancel with one of the x's in the top and make it a 2. So I'm going to get x squared. Then that takes care of that piece. So you go to the next piece or term. 4 divided by 2, that's the numbers, is going to turn into 2. The x in the bottom will cancel with one of the x's in the top, and you'll be left with just an x, right? Because that's all I see left sitting there is just one x now, whereas in the last one I saw 2 x's, right? And then the last part, you're going to do 10 divided by 2 plus 5, and an x in the bottom cancels with the 1x in the top, and that's all you're left with, and that's your final answer. Okay, that's what we call factoring by finding the greatest common factor. Okay, does anybody have any questions before I go to the last one? Okay, some of us, just to go down here, right? Some of us looked at this last question and we're trying to like find a GCF, right? There's nothing common across all 3 of these, right? So that's what this means, is that C in the middle, this means common, right? That's what it stands for. Well, I don't see anything common across all 3 of those terms, which means I can't apply that method, right? So you have to use the other method that I showed you, which is what we call the man method, right? And remember, to use this method, you're just trying to satisfy, it's like a game, right? You're trying to satisfy 2 conditions, right? The A in the word man always goes in the middle. So I write the A on top of the thing that's in the middle of this, which means, okay, I need 2 numbers that add to 6, but they have to multiply to the other number that exists there. Well, it has to multiply to 8. Right? It's at this point you're going, okay, well, I'm just going to start writing, I'm going to try and satisfy these 2 conditions. And I always start with the multiply, right? All right, okay, well, 1 times 8 works, right? That multiplies to 8, but I can't make that add to 6. So that's a problem. So I can't use that one, right? So I'm like, okay, well, if 1 doesn't work, what does 2 work? 2 times what equals 8? 2 times 4. Oh, look at that. 2 times 4 equals 8, but 2 plus 4 also equals 6, right? So once you've found these numbers, the hard part of the question is over, right? The last part that you have to do, you know what your 2 factors are that work. It's positive 2 and positive 4. So the only other thing to do to write this thing into factored form is to say, okay, well, whatever my variable is, in this question it's x, it just goes in front of the 2 numbers that I found. And you're done. X plus 2, x plus 4. Right? That's it. That's it in factored form. Okay. If you wanted to check if you were right or wrong, you could apply, right? This is like kind of it's an aside, but it's kind of reinforcing what it is that's just happened, right? You could check, like this is checking, if you're right or wrong. You could say, okay, well, I just saw at the top of this page something that looked like this, right? It's this question. Well, what did I do in this question? I did expand. And what did I say? Expansion was the opposite to factoring. That's what we saw over here in this question, right? Tried to illustrate that to you. So if I go down here to check, I can write x plus 2 across the top. I'm going to space it out a little bit. X plus 2 across the top, and we're going to write x plus 4 down the side, right? And then my job is, remember, I'm just trying to check what's happening. I'm just going to fill in the middle using multiplication. X times x is going to be x squared. X times 2 is 2x. 4 times x is going to be 4x. And 4 times 2 is positive 8. So if you write the inside out, right? If I write the inside out, the area in one line, and then collect the terms in the middle, that should look familiar. Why does it look familiar? Because it's the original question, which means I've done this correctly. Okay? They're opposite processes, right? We're checking using expand. Okay? Factor is the opposite. Okay? Does anybody have any questions? That's on your summative, so you have to be able to do that stuff, okay? And I recorded that, so when you guys sit down today, if you haven't